In the previous session, we begin with the basics of operating system and types of operating system. So in the previous class, we discussed about the general purpose operating system, and we begin with, in today's session, it is about another type, a real-time operating system known as RTOS. So we had a little bit introduction about RTOS in the previous session. Let me have a recap. A real-time operating system, or RTOS, implements policies and rules concerning time-critical allocation of all system resources, and it decides which application should run in which order and how much time needs to be allocated for each application. So as we have an example of embedded system that is built using RTOS, it is ATM machine. Each application, beginning from the inserting the card and getting the currency notes at the output. So from the first stage to last stage, each application, each process has its own time limits, and the time is allocated by this RTOS. Some of the example of RTOS are Windows CE, QNX, VxWorks, and others. So the basic of the heart of these operating system, it is a kernel, and the real-time kernel has these basic functions. Those are the task management, task scheduling, and task synchronization, error handling, memory management, interrupt handling, as well as the time management. Now, look one by one functions done by the real-time kernel. The first one is the task or the process management. So it deals with the setting up the memory space for a particular task or number of tasks, loading the task code into the memory space, allocating system resources for that particular task, and setting up the task control block for the task as well as the process termination as well as deletion. So the process beginning from the starting point of this task or a process, okay, they look same. The name of these labels, task and process, they look same, but they are quite different, task and process. So we come to know what is this task and process in the next slide. So meanwhile, we just have the introduction about the job work done by the kernel or any operating system. Those are managed by this real-time kernel. So it is the beginning of the task to the termination of the task. Those are managed by this real-time kernel. So here, what we are going to observe in the management of task, here the task is going to be loaded and memory space is allocated, as well as the termination and deletion of the task, execution of the task. Everything is task control block. A task control block is used for holding the information corresponding to a task. So when it is started, what is the execution and what is the current status of that job, that task, as well as when it is going to end, what is the time duration, everything, all the information related to that task is maintained by this task control block. Then the scheduling, the task scheduling or a process scheduling deals with sharing the CPU among various tasks. So the central processing unit is going to be shared between various tasks. A kernel application called scheduler handles the task scheduling. The kernel has special block, it is called as a scheduler, which is going to handle all these scheduling activities with respect to task or a process. So we are going to have some example of these scheduling techniques, okay, in future slides. The scheduler is nothing but an algorithm implementation which performs the efficient and optimal scheduling of tasks to provide a deterministic behavior. So we're going to have some various techniques with respect to these scheduling, how the algorithm is implemented, okay, with respect to multiple tasks or multiple processes. So those things will be handled by a scheduler block. Then the synchronization, the task synchronization or a process synchronization deals with synchronizing the concurrent access of resources as well as which is shared across multiple tasks and the communication between various tasks. So the task synchronization is going to happen by this real-time kernel process. So because the single source or multiple sources are going to be shared among all the processes. Okay, antivirus is also want hard disk while watching the movie. Okay, meanwhile, if you are watching the movie, then also the memory, it is shared with that application also, that task also. Okay, so the antivirus is also want the memory, that is hard disk, as well as the movie application, okay, the video application, which is running a video clip from that file, okay, and that file is stored in that hard disk. So all these applications are required a resource. So the resource for this example is a hard disk. So the hard disk is shared among multiple tasks, multiple processes, and we need the scheduling is also done. Management is also done. Then comes the part of synchronization. How well they are synchronized. The better use of all available resources. Okay, so those things will be managed by this real-time kernel in the form of task or process synchronization. Then comes if any errors or exceptions occurred while executing a particular task or any of the execution of that process or a task, those things will be handled by this real-time kernel itself. So it deals with registering and handling the errors occurred or exceptions rose during the execution of task. Whenever there is an error occurred at the time of execution of task, those things will be registered as well as handled by this real-time kernel. The insufficient memory, the timeouts, deadlocks, deadline missing, bus error, divide by zero, unknown instruction execution. These are some examples of these error type. So these are just an example. We are going to find so many errors with respect to hardware. So those things will be handled by this real-time kernel. Then if we look at memory management, so compared to the general purpose operating system, the memory management function of an RTOS kernel is slightly different. So in general, the memory allocation time increases depending on the size of the block of memory needed to be allocated as well as the state of the allocated memory block. So based on the task or a process, how much memory it requires, it is go on changing. It is go on increasing or decreasing, depend on the size of the block of memory need to be allocated for a particular task. Okay, so it is based. Okay, so those things also managed by the memory management. How much memory is allocated for which application? Okay, based on priorities. Okay, so based on some algorithms, based on the scheduling. Here, the kernel is going to take the responsibility allocating the memory block for a particular process or multiple. Then comes the interrupt handling. It deals with the handling of various types of interrupts. The interrupts provide real-time behavior to systems. So interrupts inform the processor that an external device or an associated task requires immediate attention of the CPU. So as we are very known about these interrupts in the microcontroller as well as the microprocessor programming, we came across what are these interrupts. So interrupt is nothing but what? It is a disturbance to the system. So whenever the interrupt is occurred, the CPU, it is going to withhold all its operations and it is going to concentrate on the interrupt. Now, which type of interrupt is occurred and what is the job? It has to be done with the help of this interrupt process. Okay, so these are the things handled by this real-time kernel in RTOS. Okay, so this interrupt is going to occur to the system for immediate attention, perform some immediate task. Okay, so interrupts can be either synchronous or asynchronous. They may come at a specific time or they may arrive at any moment. Okay, so these are the interrupts what we are going to observe. Then the last one, it is the time management. The time management, the accurate time management is essential for, obviously, for real-time operating system. So the time with respect to such operating systems. So kernel has the responsibility to have accurate time management for providing precise time reference for all its applications. So the time reference to kernel is provided by a high resolution real-time clock, a hardware chip used in such device, in such embedded system. There is a particular segment, okay, a block which is going to known as the RTC, real-time clock. It is a hardware chip which is specially designed to perform the high resolution activities. Okay, so those things will be handled by, once again, the real-time kernel. So till now we have just discussed what is task and process with respect to the kernel functions. So what is this task and what is this process, which are going to be scheduled, which are going to be managed, and which are going to be synchronized within the operating system. And then comes another part, it is threads. Okay, go for these concepts. So task. Till now we have discussed task. Simply say it is a job. It is the work done by the operating system. So the task, the term task refers to something that needs to be done, carried out by the operating system. So in the operating system context, a task is defined as the program in execution and the related information maintained by the operating system for the program. Means the task is nothing but what? It is the program which is in execution and the related information maintained by the operating system for that particular program, for that particular task. So this is the definition of the task, or simply say it is a something that needs to be done by the operating system, or another word, it is a job or it is a work carried out by the operating system. Then if you look at this term process, the process is a program or part of the program or part of the task in execution. So process is also known as instance of a program in execution. So multiple instances of the same program can execute simultaneously. So here the process, nothing but the task, the job, it is going to be split into number of segments, and each segment is known as a process. So as we say, it is a program, it may be a program, single program, or it may be a part of it. Obviously, we know what is program. Program is nothing but a task which is going to be executed by the operating system. So the part of it is known as a process, which is going to be in execution. So here the OS is going to perform all the processes simultaneously. Okay. Then if you go for threads, a thread is a primitive that can execute a particular code. A thread is a single sequential flow of control within a process. So task is the main job. The segment of a task is a process, and segment of that process is nothing but what? Thread. Part of a process which is going to be executed. Once again, process is going to be split into number of executable codes, and each executable code or a function is known as thread. So thread is also known as a lightweight process, as we said. So if I go for the process, if you consider it is a single process, the part of it, okay, part of it is known as a thread. So it is known as a lightweight process. A process can have many or multiple threads during execution. So here we come to know what is task, process, and a thread. Task is nothing but a main job done by the operating system. To perform that task, we are going to take the help of processes. So process is nothing but it is a part of a task. Then to perform that process, once again we are going to split this process into many parts, and those parts are known as lightweight process. Another name it is thread. Okay, so a process is having multiple threads, and a task is having multiple processes, and operating system is capable to perform multiple. So you just have the chain of these terms, how they are dependent on each other. So OS is depend on task, task is depend on process, and processes depend on execution of each thread. Okay, so we come across what are these terminologies. Once we deal with some examples on these things. Okay, now go for the process states and state transition. So this is similarly look like a FSM, finite state machine model, what we have discussed in the previous model. So it is also represent same thing, the process states and state transition. So here you can observe the diagram about a process. It is about process. So here you are going to observe the process is created, then it is started executing. But when it comes to the ready state, after ready state, it will move towards running while the process is executing. Then due to interrupts and other shared resources, due to other processes, it will be disturbed and it will move from running state to blocked state. After the completion of once it is released, when the resources are released to this particular process, those are once again come back to the ready state. Once again, after ready state, once again it will move towards running. Okay, so processes go on running until unless it is going to be completed. While doing one process, so due to external signals, those are nothing but interrupts, because a process is using a system resource. When another process wants same resource, then obviously the process is going to be withheld for a particular continuation. So after the completion of the complete process, it is going to move towards completed state. Okay, the respective transitions, we come across the movement of one state to another state by a process. Those are labeled as transitions. Okay, so if you look at the creation of a process to its termination is not a single step operation. So as we are going to observe in this diagram, it is not a single stage. Here the process is going to have many states. If you look at, we have 5 states of a particular process as an example. Okay, here we have, it is created state, then it is in ready state, then it is in running state, then we have blocked state, as well as it is completed state. The process transfers through a series of states during its transition from the newly created state to the terminated state. So whenever the OS wants to execute that task, it is going to take the help of the execution of task is done throughout the multiple processes, and multiple processes are going to be executed throughout multiple thread executions. Okay. So once the thread is completed, then process is going to process states and state transitions. How they are? Okay, they look like a similarly. The operation, obviously, we have studied in the previous model. It is finite state machine with states as well as the state transitions. Okay. Here we have one of the example of these threads. We have many threads with respect to operating system, but according to your syllabus, the only one example, it is illustrated here with a program, with a C program. So it is known as POSIX threads. This POSIX stands for Portable Operating System Interface. Portable Operating System Interface. So it deals with the real-time extensions and thread extensions. So this thread is the set of code which is going to be executed, okay, within a process. So one of the example is POSIX. So POSIX stands for Portable Operating System Interface, and it deals with real-time extensions and thread extensions. So it is going to use some defined libraries, and the library known as pthreads. So in the C language, we are going to use this particular thread under a library, and the name of that library is going to be pthread. We're going to include these libraries in the hash include statement. So pthreads library defines the set of the POSIX thread creation and management functions, how the thread is created and how the thread is managed, how the thread is going to be terminated, what are the errors, error handling, exception handling with respect to that particular set of code. Those things will be derived in this particular library. Okay. One of the example, the primitive, what we're going to observe, it is the one of the function which is used for creating a thread. So it is example, what we are going to observe, it is int. The function name is pthread underscore create. Int pthread underscore create. So what this int type is going to mention, it is nothing but the return type of this function. So what is the return value? It is an integer value, or this pthread underscore create function is going to return once it is called by the main program. So what are the arguments it is going to use? So it is going to use a variable. So the above primitive is a new thread for running the, and the function it is, as we are going to observe, it is a start function. Here the start function. So here we are going to observe in the statement, while calling that function, we are going to use these arguments. And what are these arguments? Meaning here the p thread underscore t. P thread underscore t is the handle to the newly created thread. Okay, means we are going to mention what is the thread ID. Okay, once thread is created, means it is a set of instructions to be executed. The set of instructions to be executed. So what is the particular ID? Okay, because same thread is used by another process. So there we need to give different ID for that. Means the thread is going to be recognized by different IDs. So those IDs are recognized by the respective label, and the label or a variable name or argument name, these are used as according to this p thread library, what it is defined in that library, in that header file. So those are the function defined in that library. It is p thread underscore create, which is going to create one thread, okay, to perform some function. Thread is nothing but a function which is going to be executed. Okay, a set of instructions to be executed. So p thread underscore t is the newly created thread ID. Then the attributes, nothing but the details about that thread. Those are kept in the constant variable, and that variable name is p thread underscore attr underscore t. P thread underscore attr underscore t is the data type for handling the thread attributes. Nothing but all the details about a thread. So how many, what are the instructions and what is the code, then comes how many variable types. Okay, all those things will be maintained by this thread under the thread attribute variable. Then which function to be executed by this, the function executed by this thread is start function. As it is mentioned, the start function is the function the thread is going to execute. So in the program there are so many functions. Okay, so when you create a thread, it is going to be pointed to a particular function to be executed with its ID as well as the attributes. Then what are the arguments? So that particular function may use some arguments, and those arguments are mentioned in while calling that particular thread creation function. So argument is the argument for that particular start function. So you can observe this single statement. So int, how the thread is created. The thread is nothing but what? Here a set of code is going to be executed. What set of code? Which are kept in a particular function. So that function is going to be called by this particular thread with its thread ID as well as the thread attributes, including the arguments required for that particular function. So all are kept in a single statement. All are kept in a single statement known as the p thread underscore create function. Once the thread is created, it is known by thread attributes variable, and which function it is executed, Once again, it is also kept in the attribute itself, which function it is executing. That is start function in our example. And how many variables it is going to use, what are the arguments it is going to use. Those things also mentioned in the attributes itself. Okay, so this is the one of the example about POSIX threads. How it is written. Then the return value of 0 indicates yes, the thread is created successfully. So keep it in mind. This function, if returns, once you return this code in your C program to create one thread, so if the return value from this function, it is a 0. If it is 0, it indicates yes, thread is created by this operating system or a kernel. If it is going to return other than 0, means any integer value other than 0, any integer value, then it indicates there is an error. It means there is an error in the creation of that particular thread. It means thread is not created. When the thread is not going to be created, when the memory allocation, the task synchronization, or any process in the kernel, it is not allowing to create that particular thread requested by a program or an application, then it is going to return an integer value other than 0. Once the 0 is returned, means yes, thread is created, and the created thread ID will be known in the variable pthread t, and its attributes details will be available in the attributes, and the function which is going to be used pointed by this thread, as well as what are the variables or arguments used by that particular function. Okay, once I go for a particular example in the C code, you will get the knowledge about all these concepts. Okay. Then once the thread is created, we need to start using of that one. So we need to call the joining. We need to call that to join. Okay. So the another function derived in the pthreads library header file, it is int pthread join, and the argument what it is going to use, it is the pthread underscore t, that is which is newly thread ID what it is created, plus another argument is what is the thread status, the status of the thread. Okay, so these are the two arguments which is used by this pthread join, and this function also returns 0 for successful connection, the successful synchronization between thread include with the reference of its IDs. So it blocks the current thread. Once we are going to call this pthread join. Once we call this to block and waits until the thread, it means what? When we call this function, it indicates yes, I want to use this thread now. In the program, I want to use this thread now. So stop all previous thread activities, because the process is having multiple threads. Even the new power button press martira in the mobile phone. So if you press the power button, it's a program. Okay. So there is a software which is running behind that power button. So how the program is executing, it is divided into, it is nothing but a task, you may say. The task it has to be executed by the operating system. So that task is divided into multiple processes, and each process once again splitted into multiple threads. Okay, here one thread is working, another thread is waiting, or concurrently they are performing. So here how they are interacted with the help of these library definitions. Okay, the creation of a thread, it is pthread underscore create, and to call that particular thread, it is pthread underscore join. Once the thread is ready and it is connected, it is at the execution time, then it is going to stop remaining thread activities, and it is going to complete its work, and it is going to return all its used resources to other threads after the completion. Okay, so these are all the activities a thread is going to perform. So if you look at this example on this POSIX threads, so here we go for one of the example. Write a multi-threaded application. Means we have number of threads. Thread is nothing but what? It is a part of the process, nothing but it is a set of instructions to be executed. Okay, so the application to print hello, I am in the main thread from the main thread. Not main function what I am going to consider it is as the main thread anta consider marthivi. Then we have within that one we have some more threads. Okay, so we need to create those things. So here another thread which is going to print hello, I am in a new thread, and both messages are printed by different threads. So one thread, that is main thread, is printing what? Hello, I am in main thread. Hello, I am in main thread. It is the statement executed by the main thread. Means thread is nothing but a function. Okay, then a program, set of instruction. Then another statement, that is hello, I am in new thread, and these two are going to be printed 5 times each. Hello, I am in the main thread 5 times. Hello, I am in new thread 5 times by using create and this POSIX primitives. So look at that program, how it is written to create a thread as well as execute that thread. So here we are going to say, as we discussed, it is going to use a main library of this POSIX thread, which are all the functions related to that. They are derived in that header file. The name of that header file is pthread_h. pthread_h. Then another library for supporting it is standard library.h, and another it is with respect to IO operation, it is stdio.h. Then to create a new thread, to print hello, I am in a new thread, the function is going to be written in this fashion. So void new thread and its thread arguments. We need some, because I need to print 5 times. No, I need to print 5 times, so I need to use a for loop. So for that for loop, I need a variable. So I'm going to declare one variable, int I. For I equal to 0, I less than 5, I plus plus. So here what I'm going to do, I'm going to use the printing statement. What is the printing statement? Printf. Hello, I am in new thread. So line by line, I'm going to observe on the screen, hello, I am in new thread. Whenever this function is called by the main function, keep it in mind. When this function is called by the main program, then immediately what is going to happen, this program execution enter into this function, and it is going to define one variable, declare one variable I. Then I is going to vary 5 times. Then while during execution of 5 times of for loop, it is going to print hello, I am in new thread. After that, wait for some time. How to wait for some time? Some standard libraries are there, standard functions are there, that is sleep. So sleep function, it is going to stop the execution of this particular program for a particular time period, and the time period is mentioned in the seconds. So here it is 1000 second, 1000 number indicates 1 second. So it is 10,000, nothing but 10 seconds. Okay. So in this sleep function, whatever the number it is mentioned, the number it is 1000 means 1 second. So 10,000, nothing but 10 seconds. After that, after printing 5 times, here we need to return null. Return null nothing but the execution is over. Then this is the particular thread which is going to be created first. After the creation, it has to be joined. Means what? It has to be executed with it using this pthread join function. Now look at the main function, main program, or main thread. So this one is the main program for this particular example. Now go for the what are the statements written in this main program. So here it is int main void int nothing but it is going to return some integer value. Then int j, because in the main, what is the program task? Main, in the main thread, I need to print 5 times one message, and in the created thread, in the newly created thread, I need to print another message 5 times. Okay, so totally I am going to observe 10 messages on the screen. So one message is I am in the main thread, another message is I am in the new thread. Now we have already written the particular thread, the new thread for that execution of I am in new thread. Now go for this, how to create the thread. So here, thread control block, let me say another variable I'm going to use TCB. TCB, it is for what? The thread ID. And to know that thread ID, I need to use a variable pthread t. The type of this variable is what? It is a thread. So how to identify that particular thread? By using the data type pthread t. And this data type is defined where? It is in the library file, which is included. Okay. So pthread underscore t is a data type for thread and thread ID. Okay, create a new thread for executing new thread function. How we need to create? With the help of pthread create. So pthread create, we already discussed in the theory part. So that is pthread previous slide. So pthread create, it is going to use the thread ID. Obviously, what is that thread ID? It is pthread underscore t. So instead of using pthread data type, what we are going to use? It's what the variable name we have used for that particular type. So it is TCB. So I am going to mention TCB here. Okay. Then some attributes. Then comes the function which is going to be executed. So this is the new function. What? New underscore thread. It is the function what we have, what we want to execute. Okay. And arguments, it is going to use nothing. Okay. So here what we have, how to create, we are using all the arguments of this pthread underscore create. So what are the arguments? The thread ID, that is TCB. Then what are the attributes? Null attributes. Then we have what are the which function is going to be executed by this particular thread? It is the thread is nothing but TCB according to this name. So the TCB is the new thread created. So that thread is going to execute this particular function. Then what are the arguments it is that function is going to use? Null. Okay. Then so here we are going to use if statement in this particular creation of this thread. Why? Because this function is going to return integer value if there is an error. If no error, it is going to return 0. Suppose if any number is returned by this pthread create, then what is if statement? It is going to be true. Once it is true, what is going to print? It is going to print what? Error in creating new thread. Because you are creating new thread, it may be created, may not. It is depend on the kernel allocation. This allocation is done by the kernel. If kernel permits, then only thread is created. If memory is created, then it is not going to give the permission to create. So then this function is going to return some integer value other than 0. So once above 0 value is given or non-zero value is returned by this function, then it is known as a error. So it is going to print error and return -1. So -1 is for what? For this main function. -1 is written, means no further execution of remaining statements. Okay, no further execution of remaining statements. Suppose thread is created, TCB thread is created, then it is successful. Then what? It is going to go for next state. What is the next statement? For j equal to 0, j less than 5, j plus plus. It is for a variable to count for 5 times. And what I am doing in this for loop, I am printing a message in the main program. So hello, I am in the main thread. It is going to run for what? 5 times. And each time it is going to wait for 10 seconds. Sleep 10 seconds. Okay, 10,000 nothing but 10 seconds. 1,000 is nothing but 1 second according to the program clock period. Okay, so sleep for 10 seconds, then execute this statement one by one. So hello, I am in main thread, 5 times is printed on the screen. After that, I need to call this function now. I need to call this thread. I need to use, we are going to use a pthread join function. Pthread join function to utilize that thread which is already created successfully. So what this function is going to return, once again it is kept in the if statement, because whatever the function it is going to return, whether it is successfully connected or not, it is joined or not, okay, it is connected or not. At that time we need to know what is the status of that particular thread usage. If it is return a non-zero value, then there is an error in connecting or using that thread. Thread ಅನ್ನು create ಆಗ್ಬಿಡುತ್ತೆ, but ಅದನ್ನು use ಮಾಡಬೇಕಲ್ಲ, use ಮಾಡೋ time ಅಲ್ಲಿ I need to call that one. So the method, it is to use that particular thread, it is pthread join. Pthread join. So what is the thread? It is TCB thread I want to use, because this TCB thread is going to use this particular function, new thread function. Okay, now go for the joining. If it is written non-zero value, then it is error and return -1. So main program is going to stop its work. It is not going to continue with the next value. So once it is successful, means a 0 value is written. 0 value is written nothing but thread is now occupied all resources of the operating system. So what is going to happen? The control is going to move from this main thread to the newly created thread. So in that newly created thread, what we are doing? We are executing some statements, 5 statements. What are those? I am in the new thread. So those things will be executed and it will come back to, after the completion, it will come back to its program, main program, and at the end we have return 1, nothing but everything is done smoothly. Okay, return 1 is nothing but what? Everything is, the process is completed. The main program execution is over without any error. If there is an error, obviously it is not 1, it is something else. Okay, it is not 0, it is not 1. Some other number will be returned to this main program. Okay, so this one is the thing what we have observed in the example of POSIX threads. Okay, how the thread will be created and how it will be used. Okay, so what are the errors are going to happen with respect to that thread? Okay, during creation as well as doing using. Okay, so this one is the today's session what we have went through different concepts. So in the next class, next concept, we are going to discuss about how the thread is going to be emitted, removed. How it is known as preemption. Thread preemption. Whenever we are going to call a particular thread using pthread join, okay, whenever we are going to start executing a thread using a thread, what this thread is going to do? This thread is going to execute its codes by stopping, while as well as by holding remaining threads activities. Okay. After the completion of this thread, it is going to go for once again return all its control to the kernel. Okay. So how mission is going to happen? We're going to call that process as thread pre. Okay. So we're going to look at this concept in the next session.